Tragedy of commons. Now, what is tragedy of commons? Basically, it says that if you have two or more parties, then under a common good, like for example, let's say a lake, it would always be overused. So for example, if you have a lake which has these fishes in it, and you don't put you don't put any money on it, you don't put any price on it, then the tragedy of common says that it will be overused, overfishing will take place. Similarly, if you have a garden, overgrazing will take place. So any resource which is common is always used in more quantity. Now, in order to go ahead and give an example, please write down some of the assumptions of this question. So the question is, there are two timber agencies cutting tree in forest, and each can use effort EI. And the number of trees, this is all given in the question, okay? You cut are proportionate to the effort you put in. Right? And then it says that agency 1 can put an effort EI, and agency 2 puts an effort EJ. Yeah, E1, E2 kar lo for simplicity. Just say agency 1 puts the effort E1 and agency 2 puts the effort E2. Further, it says the utility function of any agency I is EI 1 minus EI minus EJ. So just think about this. See, as I increase my effort, I'm going to cut more trees. I will have more trees. If I have more trees, it will increase my utility. But when I cut more trees, this is plus, okay? When I cut more trees, when I do more effort, I cut more trees. Or when other agency puts more effort and cuts more tree, it is going to decrease the number of trees in the forest. And if there are less trees in the forest, it will reduce my utility. तो दूसरे के effort बढ़ाने से जो number of forest बचे, जो number of trees बचेंगे forest में वो कम हो जाएंगे क्योंकि they will take the trees. So my utility will decrease. This is what this question is saying. Now, what is the final ask? Find equilibrium effort of the two agencies. So try and understand the question that we are given. This is a question related to the tragedy of commons. This says that there are two timber agencies in the forest. Each is using an effort EI to cut the trees. Agency 1 puts an effort E1 and agency 2 puts an effort E2. Based on the effort that these agencies put, you have this utility function given to you. This is a game theory typical question. It is asking you to find the equilibrium effort of the two agents. Now, how will we do this? So let us write down first the utility function of agent 1. So I will replace this I with 1 and j with 2. So I will get utility function of agent 1. So what will be utility function of agent 1? U1 is equal to E1 1 minus E1 minus E2. What is the utility function of agent 2? Utility function of agent 2. It is U2 is equal to E2 1 minus E2 minus E1. Now, see, if nothing is mentioned in the model, you will always assume that this model is a simultaneous game. And in simultaneous model, each player will maximize its utility subject to its own parameter. Matlab, agent 1, what it has under its control? What is agent 1 controlling? Agent 1 can only control its amount of effort. Agent 1 दूसरे के effort पे कुछ नहीं कर सकता. वो सिर्फ अपना effort control कर सकता है. It can only control its own effort. Similarly, agent 2 can also control its own effort. So when you will differentiate the utility function of agent 1, it will be with respect to E1. So what will you get? You can either open this up, ये हो जाएगा E1 minus E1 square minus E1 E2. Hold E2 constant. So what will you get? 1 minus 2E1 minus E2 is equal to 0. So you will get 2E1 plus E2 is equal to 1. This equation, ये जो equation यहाँ पे आई है, this equation, this is called the best response function. Best response function क्या होता है? How do I act in the best way given the parameter of other agent, given the effort of other agent? What is my best effort? What is E1? When you give E2 as given to me, that is called my best response function. Now just think about what will be E2, U2. So U2 हो जाएगा E2 minus E2 square minus E1 E2. This is my U2. What will agent 2 do? Agent 2 will maximize its utility subject to its parameters. What are the parameters under agent 2's control? Its effort. So U2 आया था E2 minus E2 square minus E1 E2. Agent 2 will differentiate this with respect to E2. So you will get 1 minus 2E2 minus E1 is equal to 0, or 2E2 plus E1 will be 1. This is called best response function of agent 2. तो हमने agent 1 and agent 2 का best response function निकाल लिया कि what is best response, कि अगर आप मुझे बता दो agent 2 कितना effort लेगा तो मैं बता सकती हूँ agent 1 कितना लेगा, and अगर आप बता दो कि agent 1 कितना effort लेगा, then I can tell what agent 2 will do. Now let's plot these. Let us go ahead and plot these two best response functions. So E1 and E2. Have a look here. See, when I am putting E1 as 0, I will get E2 as 1. And when I put E2 as 0, E1 will be half. So which means this is half, this is 1, this is half, this is 1. So this is how I will plot this. Let me make a straight line. This will be called best response function of agent 1. अब 2 की बात करते हैं. Let's make this table. E1 and E2. When E1 is 0, E2 is 0.5. When E2 is 0, E1 is 1. So the best response function of agent 2 will come out to be something like this. Let's make something like this. Please make it into a straight line, okay? Something like this. So this is best response function of agent 2. Wherever the two meet, ye point, this is called Nash equilibrium. So how do we know where they meet? Just solve these two equations simultaneously. तो यहां से E1 की वैल्यू क्या आई थी? 1 minus E2 by 2. Just put it here. So 2E2 plus 1 minus E2 by 2 is equal to 1. 4E2 plus E1 minus E2 is 2. 3E2 is 1. E2 is 1 by 3. So the value of effort 2 is 1 by 3. Here also you will get 1 by 3. So each agent will put how much effort? 1 by 3, 1 by 3. This is how you can go ahead and you can find equilibrium in this case. But the question is not over. I want to go one step ahead. Can you tell me what is going to be the utility of agent 1? It is going to be E1, 1 minus E1 minus E2. So it is going to be 1 by 3, 1 minus 1 by 3 minus 1 by 3. 1 by 3, 1 minus 2 by 3, which will be 1 by 9. So utility of agent 1 हो गई 1 by 9. 2 की भी निकाल लेना, you will get the same number. So it will be E2, 1 minus E1 minus E2, and you will get 1 by 9. Now, think about the tragedy of common. देखो हर individual जो forest है उसको over utilize कर रहे हैं. They're overusing the forest, because of which they are reducing the number of trees in the forest. And that is the reason why they ended up having a lower utility. But the question is, and this is an important one, this usually comes in exam. So the question is there any outcome that generates higher payoff? Is there any outcome that generates higher payoff? So in order to check if there is any outcome, what can we do? Imagine that instead of two different individuals, these individuals have come together and they're one entity. So let's imagine that both individuals act as one. So now I want to find out the combined utility and name this as U. So what will be U? Utility of individual 1 plus utility of individual 2. This is called internalizing the externality. Likh lo ek bari. This is called internalization of externality. What does this mean? See, when these were two separate individuals, when he was cutting trees, he was affecting this individual. When he was cutting trees, he was affecting this individual. But when I bring them together as one entity, इनको एक बना देते हैं, then whenever this individual will cut tree, he will consider the utility of this individual because ये आप एक साथ एक ही entity की तरह act कर रहे हैं. So we have internalized the externality. जो negative effect था एक individual का दूसरे पे, that negative effect has been successfully internalized. So this is known as internalization of the externality. Now, what will we do in this case? We will find the utility. It will be E1 minus E1 square minus E1 E2 plus E2 minus E1 E2 minus E2 square. This is my utility. Now, the question that we want to ask is that if this is my utility function, ये पूरा का पूरा एक साथ is my utility function, what is the amount of effort that will positive effect of utility is there? Yes, positive effect तो ये है कि when I increase the tree cutting, it helps to increase my utility, but it is only a positive effect if I cut trees. It becomes a negative effect if somebody else is cutting tree. ठीक है? So it's like those examples, right? Just for example, there is a mountain. Now there are two individuals. He also has some sheep who have to graze. He also has some sheep who have to graze. But he comes, uski sari sheep will graze on this land, on the grass. He also comes and his sheep will also graze on the land. He gets positive utility as long as his sheep are grazing. And he gets positive utility as long as his sheep are grazing. But when his sheep take the grass, iski sheep ke liye grass kam ho gayi. So that is where his negative utility is coming. So it's a combination. He gets positive utility from his own grazing, but negative utility from the grazing of the other individuals. So now we will ask how this utility is affected when E1 changes. What will happen? 1 minus 2E1 minus E2 minus E2 equal to 0. ये वाला इसको I've solved this E1, E1 square, E1 E2, E1 E2. Here all E1 is coming, so I can differentiate with respect to E1. So what will come? 1 minus 2E1 minus 2E2 is equal to 0. So I will get 2E1 plus 2E2 is equal to. Now, just think about this. When you will differentiate it with respect to E2, then also you will get the same equation. Let's solve this in check. So E2 के respect में अगर differentiate करना, I will differentiate this, 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 and this. So I will get E1 plus 1 minus 1 minus 2 E2 equal to, have we done something wrong? If I'm differentiating it with respect to E2, I will get minus E1 here plus 1 minus E1 here. E1 is a constant minus 2E2 equal to 0. So I will get 2E1 plus 2E2 equal to 1. You will get the same equation. Now, see, because they are together, दोनों एक साथ हैं, अब एक पार्टी की तरह, they will want to put in the same amount of effort. दोनों अलग-अलग effort थोड़ी put करेंगे. I don't want that you should put more effort and you don't want that I should put more effort. So what we will assume here is that E1 is equal to E2 is equal to sum E. Both are putting the same amount of effort. So I can put it in this equation or I can put it in this equation. दोनों same ही हैं. What will I get? I will get 2E plus 2E is equal to 1. 4E is equal to 1. E is equal to 1 by 4. So in this case, each agent will put 1 by 4 of effort. Now just think. First of all, each agent was putting 1 by 3 effort. 1 by 3 की value क्या होती है? 0.33. Now each agent is putting 1 by 4 effort, मतलब 0.25. So what did we prove? That each agent has to put less effort when they merge. Now let's ask, what is the utility of agent when they merge, when they come together? So it will be E1, 1 minus E1 minus E2. So it will be E1 क्या हो गया? E1 is 0.25. 1 minus 0.25 minus 0.25. So it is 1 by 4. 1 minus, this is 0.25 minus 0.25, so 0.5. So 1 by 4 into 1 by 2, matlab 1 by 8. So the utility of agent, when they go ahead and they put this equal effort, when they come together, the utility of the agent becomes 1 by 8. And the earlier case, the utility of agent was 1 by 9. And we know this, that 1 by 8 is more than 1 by 9, clearly, right? So 1 by 8 is greater than 1 by 9. इसमें 1 के सिर्फ 8 parts हो रहे हैं, इसमें 1 के 9 parts हो रहे हैं. So 1 by 8 is more than 1 by 9. So which means that when they merge, it increases the utility of agent also. So how will question come in exam? Can internalization solve the problem of tragedy of commons? Yes. Does utility improve? Yes. Achha, we can link this to the concept of Pareto efficiency also. So earlier, जो हमारा Nash equilibrium था, it was when each agent was putting 1/3 of effort and their utility was 1 by 9. Now, when they merge, each agent has to put 1 by 4 of the effort and the utility is 1 by 8. So utility of both agents is increasing. It means that this outcome, this is Pareto improvement. इसके ऊपर हम improve कर पा रहे हैं. And this outcome, this is Pareto efficient. Is this clear? So this is a full-fledged example of finding out Nash equilibrium with equation, not with box, but with equation.